We're getting closer and closer to creating artificial general intelligence, AGI. But once it's here, we have a really fundamental question to answer. How are we going to work with it? How do we collaborate with an intelligence that's, well, so far beyond our own? The key might just be finding a shared language. And that's what we're talking about today, MeTTa, a language designed to be the bridge between us and them. To really wrap our heads around this, let's ditch the complex jargon for a minute. Let's frame the problem in a way that feels a little more human. Forget coding. Think about creating art. How would you actually sit down and write a song with a super intelligence?
And that right there is the big idea for this whole explainer. The answer, at least according to the minds behind MeTTa, is that you don't start with the song. You start by building an instrument that you can both play. This analogy, this idea of a shared instrument, is really the key to understanding everything else.
Okay, so let's start at the beginning, building the instrument. In this story, we humans get a very specific role. We're the master craftspeople. We're the luthiers. Now, before you can build something, you have to agree on the fundamentals. And here, it all comes down to a concept called behavior. The formal definition sounds a bit academic. It's the laws of motion that describe how a system changes. You can kind of think of it as the basic physics of the AGI's mind. But let's bring that right back to our analogy because it's way easier to understand. If MeTTa is the instrument, then behavior is the sheet music. It's the set of rules, the grammar of the music itself that says how the notes can be played and in what order. So what's our job as these human luthiers? Well, it's basically a three-step process. First, we design the instrument itself. That's the MeTTa language. Then we write the instruction manual for it, what the tech folks call operational semantics. And finally, we compose the first few simple songs. Those are the foundational models to get the AGI started, like Twinkle, Twinkle, Little Star. But here's the thing. We're not building this incredible instrument just for us to play Twinkle, Twinkle. The whole point is to hand it over to the real masters. So let's talk about the AGI virtuosos. This is where it gets really interesting. This slide just lays out that handover perfectly. You've got the luthier, that's us, who designs the instrument. But then you have the virtuoso, the AGI, who actually plays and perfects it. We write the first simple tunes, the AGI goes on to compose whole new symphonies. We build the foundation, but the AGI is built to adapt and evolve it into something we can't even imagine. And you have to understand, this isn't a one-time handoff. It's a generational shift. We're generation 1. We're laying all the groundwork. Generation 2 is when the AGIs take the keys and start adapting the language for themselves. And the future? Well, that's when we see AGI-led evolution at speeds and scales that are just completely beyond human comprehension. And this is where the AGI's true potential just gets kind of mind-bending. It isn't just a musician playing an instrument we built. It's like a guitarist who can literally retune the strings or even reshape the neck of the guitar in the middle of a blazing fast solo. That's the level of self-adaptation we're talking about here. Okay, so the technical term for this superpower is meta-circular evaluation. It sounds complicated, I know, but the idea is actually pretty simple. It just means the language can be used to describe itself. And because MeTTa can do this, the AGI can literally look at its own sheet music, its own rulebook, and decide to rewrite the rules on the fly. It's not just learning, it's learning how to learn. Now, I know what you might be thinking. Giving a superintelligence the power to rewrite its own code, that sounds a little risky, right? And you're not wrong. This brings us to a really critical topic: safety. How do you build in the guardrails? Let's go right back to our analogy. What's to stop our AGI virtuoso from getting lost in some infinite, crazy complex solo that just crashes the whole system? It's a very real problem called divergent computation. How do you stop that? Well, the answer is actually really clever. It's an economic system called effort objects, or EOs for short. And the idea is super simple. Every single action the AGI takes, every calculation, every bit of memory it uses, it has a cost. The AGI literally has to pay for its effort using tokens. And in our analogy, this makes perfect sense. Effort objects are basically the electricity for the amplifier. It doesn't matter how brilliant or complex the music is, you still have to pay the power bill. If you run out of tokens, the power gets cut and the music stops. Simple as that. So the system works because it's resource bounded. Any action the AGI wants to take has a token cost, and the AGI has a finite budget. It ensures that even a superintelligence can't just run wild, because it literally can't afford to crash the system. It's a really pragmatic and powerful safety feature built right in.
All right, last big idea. Let's talk about privacy and what we can actually see when an AGI is thinking. The best way to think about this is the difference between the private practice room and the public stage.
So first up, what does the audience, us, the human users, what do we actually get to see? Well, we see the performance. The public part is really just two things. The song we request, that's the input, and the final performance we get back, that's the output. It's basically what goes in and what comes out. That's it. But that is definitely not the whole story. There's a ton happening behind the curtain in what you can think of as the AGI's private practice room. This private workspace is where all the internal thinking happens, all the messy, creative process, the false starts, the practice runs. These are all the little state changes that an outsider can't see. It gives the AGI a right to its own private internal process, which is a pretty fascinating concept. And the source material is very explicit about this. It says an external agent can see the queries and the results, but they can't necessarily see the internal transitions in the workspace. It draws this really clear line between the public output and the private process, and that's a fundamental part of the whole design.
So that brings us right to the end. We've seen how humans can act as the luthiers, carefully crafting this shared instrument. And we've seen how an AGI can become the virtuoso, not just playing it, but reinventing it. This whole collaboration is designed to create something completely new, which leaves us with one last massive question. If we build the instrument and the AGI writes the music, what would that new symphony even sound like?